Let me go ahead and introduce our guest today. Rachel Reddick received a PhD in astrophysics from Stanford, but realized that she wanted to do more down-to-earth work. After some exploration, she switched into data science. She first worked as a data scientist at Bosch, a large manufacturing company. Afterwards, she joined Coursera, where she has been for almost 2 years. Without further ado, go ahead, Rachel.
Okay, so let me go ahead and share my screen. So I set up some slides more or less as a backdrop, so that basically is supporting comments here. So if there are questions that happen along the way, I'm happy to divert from what's currently in the slides. So I'm going to expand just a little bit on what Laura said regarding the, my career path, since it sounds like there's some interest in, how did I get to where I am, as well as a few words about other data science things I've worked on, which will eventually come back around to a few of the questions that I know people have asked in the data science community that will hit some of those very much at the end. That middle part, I'll be talking about that skill graph thing. So what is it and where it came from, which I know people are somewhat curious about it, as well as what's the point anyway, which eventually ties into how it helps, things on Coursera, such as our search algorithm, as well as a couple of other things. And what else are we going to do with it in the future? Well, there's a whole bunch of exciting things that I will talk about a little bit. And then it will be wide open for your questions. Okay, so this is basically a doodle of what Laura said about my background. I did a PhD in astrophysics. It was a lot of fun looking at galaxies and dark matter and how the universe is structured. And it's both not super applicable to life on Earth and, well, the job situation for astrophysicists is not great, surprisingly enough. So I did explore some things. I did some science writing. I did some teaching. It was okay, but not really what I was looking for. But I had learned a lot of the data science skills that I eventually later use, like coding in Python, analyzing data, understanding large data sets. So I went through a program called the Insight Data Science Fellowship. It's one of multiple different programs for helping people transition into a data science role. And then I worked at Bosch, where I did things very different from what I'm working on now. I actually did a certain amount of time series forecasting work. And they have their own interesting data science problems, which contrasts with the ones that Coursera has, which are all focused on how people learn things and how do we find the things that people want to learn and all of that good stuff. And I've been here for about 2 years. So it's been good times, and I'm looking forward to being here for a while longer. Other things I've done. So as I mentioned, things at Bosch have some classic, essentially machine learning problems, like can we predict which widget is going to fail, which is actually really interesting because they don't have a lot of failures. Similarly, and as I mentioned also, there's some forecasting time series work. At Coursera, things I've done in the past, I've done some improvements to search. One of those that you might note is that if you see the drop down in the search box and you look at the suggestions, I had put in a certain amount of work on getting those suggestions to be a little bit better. And another piece that I've worked on is recommendations, including you'll get a weekly email with some recommended courses. I've worked on that. I've also worked on some of the recommendations you see elsewhere on the site, such as your dashboard. The big thing I've been working on recently, though, which I'm really, really excited about, is all of the skills stuff. So skills. So skills graph. So this is a diagram that we have of sort of pieces of the skills graph. And a lot of it goes back down to why do we call it a graph anyway? So a graph is sort of a mathematical construct. If you take in some particular kinds of math courses, you'll see these. They'll also show up in a computer science context. But it's basically you have a series of nodes, which are things like a skill or a course or a quiz or a career or a person, and then you have edges connecting all of the things together. So the edges could be all sorts of things. Different things could have different kinds of edges with different meanings or multiple different connections. So for example, you see, in this particular example, the skills are at the middle, and we have content, which includes courses and specializations, and you have skills that might be a prerequisite for a course or something you learn in a course. Usually something that you learn in a course is also assessed in a course. You'll have a quiz about it or something like that. And then there's, okay, what skills do you need in a career? That's a different kind of connection. What skills is a learner, for a person on our platform learning? Is it a goal for them to learn this particular thing? Is this an outcome that they've received after taking a course? And then you can have also these relationships between skills, between different skills with other skills, for example. For the skills graph as it currently exists, I'm going to focus mostly on where did we get these skills anyway? What skills are, how skills relate to other skills, and how skills are taught in courses. And those are sort of the core of what we're using right now. A lot of these other edges are in progress in various ways, and I'll talk about that more later. So this first thing is, I'm going to talk a little bit about what those edges are. So those edges, that first one is parent of. What's a parent skill? What's a child skill? It's more or less what you might expect, is that you have a parent skill as a big, broad skill, like data science. That is a big category. And then the child that it has, that connection here is represented by an arrow, is going to be something a little bit more narrow. So you can have a relationship, maybe data science is your big skill, and then that includes things like data management and statistics and machine learning. It might have some programming in there, all sorts of, it's essentially narrower, but still pretty broad skills. And then those skills can each have their own child skills that are a little bit more refined, and so on. And so you can basically go from a really broad skill like data science at the top down to a really narrow skill, for example, like understanding how to use a specific package in R. That might be a very narrow skill for some important R package. And we have a relationship that basically goes top to bottom, step by step through all of those. I'll also note that it is possible to have cases where, you have, in the drawing here, you see it, a broad skill obviously has many small skills under it. But in some cases, one of those child skills, one of the narrow ones, can be a part of two bigger ones. Basically, it has more than one parent. So a case of that might be, understand, a small skill like using a particular machine learning package in Python might have relationships to both knowing how to do machine learning, but also knowing how to program. And those broader skills might have that as a shared child skill, for example. So that other category that is taught by Edge gives you this connection between skills and courses. So for example, in Andrew Ng's machine learning course, which I'm hoping you've all heard of, you have broad and narrow skills, all of which are tagged to that course. So you learn machine learning, you learn about regression and classification, neural networks, which are a little bit more specific, but you also might learn about things you don't expect. There isn't a whole lot about learning how to program an Octave as being a primary purpose of the course, but you might learn that anyway along the way. So that's something that we need to make sure that our skills graph, as we construct it, includes. So back to that, where did it come from? So I've been talking about these edges and what they mean, but we also have to get this list of skills somewhere. What is the set of skills that are possible? What is this hierarchy of relationships between skills? That's the parent-child part. And what's the relationship between skills and our content, courses, specializations, and so on? So we basically do those in order. First, you figure out what your skills are, figure out how they're related to each other, and then start relating them to Coursera's content. Those first two steps, we did them a mix, essentially parts of both of them at the same time, and then refined them. So the key thing that we ended up starting with is, well, humans have a pretty good understanding of what skills are. So for example, something like Wikipedia is going to have a pretty good, essentially, data set of people relating things to each other, linking one thing to another, so related topics end up being tied to each other. So in this case, we ended up scraping Wikipedia for skills and then post-processed it and used that to both get our, to help us develop that bank of initial skills, as well as figure out the relationships. So, if you have a big Wikipedia article about data mining, it may then link to a number of more detailed things within that page, for example. We also have to do some post-processing. You have to delete things that aren't real skills. You have to add some things. So you notice in the example here that we've got R programming language as a thing, as a skill. But you could also write that as just the letter R, or as R programming, or R language. And we essentially have to add those aliases so that we know if somebody talks about our language, that they're talking about the same fundamental thing. So we have to collect what we call aliases as part of this process. Then there's another, the usual other sorts of things you expect with a natural language processing thing like this, where you have to combine some things that are very similar with each other. And, we have to do a certain amount of maintenance to make sure that the skills graph essentially stays together the way it should. And based on that, all of those pieces, we built sort of our standardized model and merged it into the existing pieces that we have. So those most broad skills, data science, computer science, those at the very top level, those are standardized labels that we had already classified courses into. So for those really big categories, we're already good. It's getting all of the more detailed skills set and essentially combined with all the courses we have that's a little bit trickier. So this is how we got the core of the skills graph. Here's the skills, here's how they relate to each other working. What about getting it associated with courses? Well, first of all, we essentially had to build a seed input. You can't do essentially data mining with no data. So what we did is we took our essentially bank of skills and we looked at first on for the content that exists. That could be transcripts, it's descriptions of the course, it could be words that show up in assessments or quizzes and so on. And we essentially look and say, okay, how often does the word for this skill show up in the course? It's sort of the most basic thing. Second, since this was essentially a number of years ago, we had, looked at the instructors that we had, and we basically asked them to say, hey, we think these skills might be taught in your course. Can you tag your course with the skills that your course focuses on teaching? So if you have a course about game design and some of the various topics associated with that, maybe you tag some of these skills to that course. So that gave us essentially an initial set of data where we can say, hey, we can now classify these courses as being associated with these skills. And that got us a pretty good part of the way there. And we built essentially a first model with this as the essentially the labeled data set that we already have. So we're in a situation where this is what's considered, before building this initial set of initial existing tags, we're in an unsupervised problem where we're trying to associate some courses with some skills, and we don't have any truth data. We don't know what the real answer is. So this gets us some of that. And from that point, we build essentially a classification model to try and classify courses into categories of which skills should be associated with them. And each skill is treated as a class. So that gets us one part of the way, but we realized that we can do better. So in many cases, instructors don't necessarily have time to tell us, how do I view the chat from here? I can't read the question right now, unfortunately.
Is it because, can you hear me, Rachel?
Yes.
Is it because you're doing a screen share? Do you not see the options at the bottom?
I don't. unfortunately.
It might be because, are you using full screen mode?
I'm full screen presenting. If I drop back, yeah, it's because I'm using full screen mode. That's
Okay.
okay, let me see.
I can read you the question if that would be helpful.
Sure. I'd have to stop sharing, I think, in order to see it.
Yeah, would you like me to just read you the question?
Please.
Okay. So the question is, do you collect the tag information is taught by and what you will learn about this course? Some courses have this information under about this course.
Mm-hmm. So for that initial data set of tagging, yeah, we would look at the course description would be one of those places where we look for, is a skill mentioned in the about this course section, as well as looking into the course content. So that was definitely an input. So in addition to the other steps that I mentioned, asking instructors for feedback. The sort of next step after that, after using some of that information, is to ask for feedback from people who complete the course. So they finished the course, they've been through all of the content, they know it's in there. So if you finish a course and gave us feedback and hear what skills have you learned from this course, you helped us with our skills tagging. Because we basically use this initial skills-based model. The initial model gives you a suggestion. So it basically lets you auto-complete things. So if you start typing in linear, it might finish it out to linear regression for you. And then we collect that feedback to say, hey, yes, indeed, this course is clearly teaching linear regression. But because we essentially use the listings of, let me back up. But you can still type in other things. Like if you learned linear regression in this course, but you also learned magic tricks, then you could put magic tricks in as something that we didn't expect as a skill that you learned from the course. And it turns out that, we basically use those as input to a second model to essentially build on top of the previous one, because we only asked instructors to give us exact skills once. And we often find that the course descriptions may be missing important information or missing important skills. For example, there's a couple of interesting examples. One of those involves soft skills. So there are courses about, how to, do public speaking, for example. People have told us that they learn about how to be confident, about confidence from those courses. And that's not something that appears in the actual, in the context essentially in the text of the course. But we find that people are learning that anyway. Similarly, in some of the technical content, people may be taking a course on machine learning, but in terms of skills that they learn, they're talking about learning Python packages. So they learn Python as part of the course, but it's not an explicit goal of the course. It's not something that shows up in the original description. And we can actually find that information and realize, okay, this course would actually be associated with this skill, even though it doesn't show up in the official course text and isn't something the instructor thought of. All right. How about we see if I can figure out how to actually see the questions. So I'm going to stop sharing and then I'll try resharing again in just the window. There we go. So it looks like there was another question. Okay. All right, looks like those questions have been handled, so let's move on. So that leads us to, what does the skills graph do anyway? So what is the point of having this really interesting thing that tells us what is taught in courses in a way that's related to these sort of skills that summarize what you learn in the course? So one of those things is that it can improve the search experience. So if you're looking for a course that teaches you how to use NumPy, the Python package, a lot of courses aren't even going to mention that. They might teach you how to use Python, but they won't mention the package. So if you search for NumPy, that without us doing anything, you might not find what you're looking for. However, when we have these skills tagged to courses, we can add those as a search field. So now you can actually, essentially have a search field that lists out skills relevant to the course. So in the example that in the NumPy example that I mentioned verbally, you can now find courses about Python by searching for NumPy, because that's an introductory Python course and it teaches you how to use that package. Another example might be p-value. The search engine by default would parse that to p space value, and you end up with courses like value chain management because the title matches. Oops. But with skills as a field and search, you can now have that match the skill field. And we can say, oh, actually, you're looking for how to do statistical inference, how to do hypothesis testing, and related topics, and essentially pull that content to the beginning. So that actually drove a pretty significant improvement in people's search results. All right, one of the other things going on, so as a bit of background, I'm sure a lot of you are more familiar with familiar with the consumer side experience, where we sell to anyone who, basically anyone who wants to, access Coursera, audit courses, take courses, can get onto Coursera to do that. We also sell access to companies, so they can provide Coursera's courses to their employees either as a benefit or for training purposes. But because employers are doing this, they also want to know what they as an employer are getting out of it. What are what employees doing? What skills are they learning? So this leads to an application that's fairly recently launched called skills benchmarking. This has been worked on by one of my colleagues primarily. Roughly speaking, this involves looking at who's taking what content, how are they doing in that content, what scores are they getting on the quizzes, are they finishing their courses, that sort of thing, and essentially assessing roughly how much they're learning in different topics. So this is an example case showing essentially, okay, how are you doing in business topics or computer topics or data science topics, for how are your employees doing in general in this category. And there's a number of other pieces here involving how are your individual teams within your company doing, how are you doing compared to other companies in your industry. Are you top of the heap, you're doing a great job training your employees, they know what they're doing, or maybe you're not actually competitive and you need to focus on, maybe you're a little bit behind and need to introduce some more, courses about, how to do statistics to your employees so you can catch up with the other companies. So another application that you can see as anyone coming to Coursera's website is we actually have skills on our course pages now. So the top few skills associated with courses. So we have, because we use a classification model, we have essentially a weight saying how sure are we that this skill is associated with this course. We can take the most certain, most likely skills, and those actually show up on your course pages. In some cases, for instance, like machine learning, that the skills that you're learning might be fairly obvious. But in other cases, particularly for things like soft skills or tools that you learn as you go through the course, those might be, essentially give you some additional information about the course relative to that summary description. So by default, this is all coming from that skills graph that we've already built. But a course instructor has the option of looking at the results and saying, this is not what my course is actually teaching. You say I'm teaching linear regression, that's not true. We're not, and get rid of that skill and add a different skill, such as neural networks or something like that. Or they think it's just more important that neural networks appear and they don't want to confuse people with the other skills that might happen to have gotten listed. And that's one of the things that we're planning on doing in the future. Is I mentioned we have, we're continually using the input from learners, from people taking courses, to help us improve the skill tagging model. Well, this gives us an opportunity for instructors to also give us some more information about what is actually being taught in their course, by essentially overriding what the skills graph does. And while we haven't built that into the skills graph yet, we're planning to. So I'm looking forward to taking that data and merging it into the rest of the model. All right, so speaking of other things that I'm looking forward to doing, so I sort of circled a bunch of the edges and sort of the skills graph blob in the center when I was, talking, showed you this picture earlier. Things that we're doing in the future, aside from doing some improvements to the tagging itself between skills and courses that I mentioned, is working on some of the other edges. So for some of these, you might eventually see things where we ask people on the platform essentially about their relationship with skills. We might ask if something is someone's goal or if it's an outcome. After taking this course, I knew this particular skill so much better that I was able to do some new and amazing thing. We're also looking at relating skills to careers. So what skills do you need for a career? If you're interested in entering this career, what skills do you need to learn? And then what courses do you need to take to learn those skills? So we're looking at that sort of framework. The part that I'm most excited about and in the middle of working on is these requirements and assessment pieces. Essentially saying, okay, what skills do you need in order to take this course? How good do you need to be at math in order to take this advanced calculus course, for example? How well do we understand these quizzes? Is this quiz assessing? I mentioned that the tags we're talking about are all at the course level. Is this individual quiz going to assess your machine learning capability or some other skill taught by this course? Is it more about linear regression? Is it more about neural networks? That's, getting some of those more refined associations is going to be interesting. But the requirements, if we want to know is something required in order to take this course, how well do you learn this skill by the end of the course? Those are things that we think we might be able to measure, but it's tricky. So this is a big blob of text. But the basic idea is, how do we measure how skilled someone is? How do we tell that you're a whiz at machine learning? How do we tell that you're really great at Python programming? Well, the obvious thing is we can measure, as I mentioned for the skills benchmarking early applications, we can look at how well people do on quizzes and assignments and courses, and saying that people who do better on that content in terms of, they finish it, they get a good score, those people probably have higher skill than people who haven't essentially taken that content yet. And that's sort of the basic level. But there's a built-in bias that we're having to deal with, which is, what if a course is so hard that only really skilled people take it? So if a course is really hard and only people who are really skilled take it, then the pass rates might actually be very high. It looks like this is really easy content. Everyone passes this. Everyone who attempts this quiz passes it, and nobody ever fails it. But it's because everyone who might have had a little bit of a struggle or a challenge with it was intimidated by the course and didn't even look at it. So we have to find some way of fixing that. Part of the solution that I'm currently working on is looking at both learners and questions and setting them up such that questions have their own score, which is not necessarily directly related to how often people pass that question. It's more about, if a learner who you already know is really skilled, takes this, tries to answer this question, take a quiz, finish a programming assignment, and has trouble with it, that suggests that it's pretty hard. And then at the same time, in order to figure out who has a high skill, we have to look at, is this person taking and passing content that is very challenging? And we have to do those two things at the same time. We have to essentially have a unified solution, because otherwise, if you end up with this bias causing, people who are actually taking really hard content to not look like they're, as skilled as they actually are. So that sort of core piece of figuring out, okay, what level of difficulty is this question? What level of skill does this person have? Is something that I'm in the middle of working on at the moment, and it's there's an intriguing potential solution, but we'll see where it goes. Once we have those scores ready, it unlocks a number of intriguing applications. So we could do things like have a better estimation of how hard is this course. If you've already taken a course and you're looking on to do another one, then we have an estimate of your skill, and we could say, this other course is about the right level for you, but this other one would be too hard, and this one would probably be too easy. It gives us a better way of recommending content, as well as potentially a way of helping filter through search results, filter by courses that are close to my skill level. That would be a modest challenge, but not, that would be a little challenging, but not too challenging. And it also gives us some other things involving, okay, how much of this skill do you need to enter this career? Well, you need people who are in this career on Coursera have skills at this level. So maybe we'll suggest that you take this course that helps people go from a low skill to a medium skill, and that'll get you where you need to go. And that's, something I'm really looking forward to working on in the future, is once this whole thing is ready to go. But it's a big project with a lot of moving pieces right now. Okay. All right. So with that, I'm going to, I had a few notes on questions from the community forum. And so I'll just go through those fairly quickly. And then I think there's probably plenty of time left for questions from other folks. So on the community, so on the skills graph side, I hope I answered, there were a lot of pieces to that question, and I hope I got the whole thing. The one part that I didn't have in my original slides was who was working on it. The answer is a lot of folks on the data science team, past and present. So there's several folks who have worked on it in the past. The two people who are working on it, doing most of the work on it right now, are me and one of my colleagues, Vinod. Vinod in particular has been working pretty heavily on the skills benchmarking part. Let's see. So someone asked whether it was worth it to learn time series analysis versus learning about RNNs and similar. And I'm going to hedge and say it depends. I have done a certain amount of work with time series before. I've also used RNNs for another different project. It's very much it depends on what you're doing with it. I'd suggest learning at least the basics of time series analysis, even if you're going to end up doing mostly neural network stuff, is useful, at least in the sense of knowing what some of the problems are, what kinds of biases you can end up with in a time series problem, how to handle the different attributes of a time series problem, if something is growing or shrinking over time, or if there's periodic variations, different sorts of seasonality, yearly seasonality, weekly seasonality, basically things that repeat, and different features like that. So the answer is, it depends. It's useful to know at least the basics, probably. Let's see. There were also a couple of questions about sort of career things, finding a volunteering or part-time position, finding a job after getting a master's degree, and looping back to where I came from. I'm not super familiar with either topic. I have not done a lot of volunteering or part-time work. I actually don't have a master's, so I'm not super familiar with either topic, and mostly it's going to be the same sort of general advice you'd get elsewhere. Check out your general area, see what companies there are and what they're working on, and see if you can't find a way that your skills might be, related to what they do. Someone else asked, I think data science for domains. I don't know for sure. I do know that we're adding a whole bunch more healthcare related content in general. I know there's at least a little bit of data science, healthcare stuff, a lot of genomics that I've seen floating around on the platform, but I think that there was a reference to another person to ask in the community forums. That person might be a better resource. Someone else asked about hard versus soft skills in the skills graph. So this is actually a really intriguing thing. So one thing that we found very encouraging about essentially requesting feedback from people taking courses is that the soft skills show up. They show up even if the instructors don't talk about them. So I think communication and confidence were a couple of the soft skills that appeared, even though we weren't necessarily looking for them, which gives us pretty good confidence in essentially our model. Is, you're taking a course on public speaking, and you see, communication and confidence show up as the soft skills associated with that maybe aren't explicitly mentioned in the description. So this is something we're planning on essentially doing more investigation into, is how do we making sure that we still get, basically making sure that that stays true in the future, and that we keep having, that useful information. The good understanding of things that are a little bit surprising but actually make sense. Someone else asked an R versus Python question. Someone who had fallen in love with R, I believe, and was looking to trying to move into R, but was worried that Python was dominating the space. So I will caveat everything that I am about to say with that I personally prefer Python over R for any number of reasons. However, Python isn't perfect. It isn't always the best tool for the job. In particular, R is better for doing heavy statistics work. It's better for certain types of inference problem. It has a lot of good time series analysis pieces in it, to reference an earlier question. Well, I personally am inclined towards Python. I'll note that the team at Coursera uses both, depending on what we're doing with it and personal preference. So I wouldn't necessarily be too afraid that R is going away. I think that both of them are going to end up, my personal expectation would be that both of them are going to end up being used for a long time. All right. And I think that more or less ends the slides that I had. So at this point, I can open things up to questions or go off into more details on some things.
Thank you, Rachel. It looks like there are some additional questions that people have posted in the chat feature. Yeah, it looks like there's maybe 3 or 4 even.
Let's pull those out.
Okay.
Let me stop sharing since slides won't necessarily show up. All right, so let's see, in order after video slides. So do you have your own search engine, or do you use something like Solr? Was it difficult to add a new module to existing infrastructure? Ooh, that's a good question. So that's actually a really interesting one, because we used to use Solr. So for those of you who aren't familiar, Solr is an open source search engine that you can basically take it. You'll create what's called an index. So you have basically sort of like having each index page is a set of fields about whatever thing you're searching for. And that search engine knows how to go through the index to basically match words in the expected way. So we used to use Solr. And it was actually, my understanding is that actually quite challenging to work with Solr once we were building out some of these more, particularly as we were building some of the more complex changes. So things involving the skill tags, it was a pretty significant effort to get that included. It wasn't too bad, because the first thing you have to do is basically just add the skills to the index. And then you have to do some hand tweaking in order to decide, okay, how much does a match to a skill mean versus a match to the title, and decide what the ranking scores are. So it was a significant challenge. However, we've recently actually switched search engines to a commercial one called Algolia, which works a little bit differently. So we still have the skills as an indexed field. It's still possible to show up in search, but the algorithm itself is different. And we switched over and to essentially the new engine. We've made sure that everything works more or less the same as it did before. We do have, and the big advantage of switching to Algolia is it's much easier to make algorithmic changes to the search engine. It's much easier to basically play around and try out new ways of searching for things. So we've done a few initial tests there. We're hoping to do some more in-depth ones in the future, especially now that it's easier to make changes. Okay. All right, so not wanting to go back to grad school all over again. I can totally get that. So someone mentions they're new to the data science, data analytics side, transitioning over from another subject area. I don't want to go to grad school again. Totally makes sense. What to do for self-directed learning. So in my experience, I ended up doing a certain amount of self-learning before. I mentioned I went through a program which in between grad school and elsewhere, which was useful for me. In my particular case, I mostly needed to learn a lot more of the jargon and some of the domain related things, like how do you what does data look like when it comes from a computer website instead of a telescope. So I think it depends a little bit on what subject area you're looking at. But I did find engineering's machine learning course super useful. A lot of it was familiar, but a lot of it was, I was familiar with the subject matter, and you may find that too, especially if you're someone who has past experience. But I just didn't know what the words were. So it was about learning the jargon and about thinking about things a little differently. So that course was super helpful. Otherwise, there's any number of resources. If you do a little bit of Google searching online for, learning about what is data science, what does this field do? So the best summary I've seen as a data science is someone who does statistics better than a computer programmer and programs better than a statistician. So those are kind of the two, pieces to look for. To essentially understand those two things and how to make them work with each other. So those are some potential starting points, but there's a lot of different options, I think is my best summary. And if you can find something to practice on, a lot of the Kaggle competitions are not bad. Ways of it's basically getting a practice problem and figuring out how do I solve this. Super, useful from a practical way. Yeah, so another R versus Python question. Yep, I honestly have no idea whether R is I love Python. Other people are still using R a lot. I think saying R is gone or Python is going to go away. Both of those are probably not so right. So, okay, yeah. I think any of the work you've done can translate to non-Coursera communities, specifically machine learning developers. So let's see. It's an interesting one. So I'm not sure. I know that some of the things that I've worked on are very specific to Coursera. A lot of it is essentially taking things out of non-Coursera communities and putting them into Coursera. So essentially using applications that we've seen elsewhere and putting them into Coursera's context and using them that way. And a little bit less of going the other direction, just because a lot of our outcomes are dependent on our specific data. But it's hard to say. We'll see. Some of the things I'm currently working on might be interesting for, I don't know about machine learning developers, but they might be interesting from the sort of the education related data science analysis point of view. So trying to understand how people learn skills as they, gain skills as they go through course content, for example. That might end up being interesting for other people as well. If it is, we will probably go ahead and share that general idea. We'll see. Do we have a knowledge engineer on our team? I'm not sure what you mean by a knowledge engineer. So I'm familiar with the idea of having an ontology, basically a knowledge structure. So basically how the different knowledge pieces are related to each other. We don't have someone who does that specifically. There are certainly data engineers on our team who help us maintain the systems that we're currently using, as well as help us, make sure the data is clean and reliable and all of those important things. But I definitely don't know that there isn't a better ontology for our purposes. In fact, would not be at all surprised if we could optimize that to make it better. So basically, we're at the point of this is good enough for now, but we expect that as we get more information about how courses are related to skills, that this is going to end up changing in the future. There's also some topic areas where we have a little bit less data than we might like. So for example, Coursera has a lot of really strong data science content, but we don't have, speaking as a physicist, who only knows so much about other things. We have maybe a little bit less, music and fine arts content. And so some of that skills graph is a little bit less, it has a little bit less data behind it just because there's fewer people telling us things about it. So in those areas, I think that there's probably some significant room for future improvements. So I think we'll see where that ends up going in the future. Okay. Is there any feedback function in is parent of? For example, required by career changed because of workplace. So right now there isn't an explicit one. We've had, so for most of those, that essentially the ontology structure relation between broad skills and narrow ones, we've mostly been relying on, that initial structure plus human curation. Having someone who's familiar with the topic area look at the relevant part of the structure because the whole thing is big, but looking at the relevant piece and then trying to figure out, okay, does this skill relationship make sense? Does this relationship make sense? The one place where we found we don't have explicit feedback there. We do have essentially some sanity checks, so we can say, there's something weird in this structure. Something is wrong with the structure. Someone needs to look at it and fix it. One example might be if you have a loop. So if you have a parent who's, basically apparently the child of the parent is also the parent of the child is also the parent of their parent. That's a problem. So we do that's all been fixed. But right now we don't have explicit feedback, and it might be useful to include. Essentially looking at, this broad skill, this narrow skill associated with the course, for example, is the broad, bigger picture skill also associated with that same course? If not, maybe they shouldn't. If the parent skill is not associated with the course, the child skill is associated with, maybe there's a problem. Maybe it's a problem in the tagging, but maybe it's a problem in the structure. So it's an interesting idea to build in some feedback, but it's not something we have right now. How important is understanding the business domain for a data scientist? So I think the answer there is it probably depends, but you need to understand it well enough to understand what questions people are asking and then figure out what they're actually asking. So for example, and even if the question is possible to answer, I think an example that I can give from some of my prior work back at Bosch was you have to understand the business domain well enough to know what questions you need to ask so you can solve someone's problem. For example, let's give a sort of generic example. You have a manufacturing plant, and they have some widgets that they're making, and occasionally a widget breaks. And they don't want that to happen. You sell it to somebody, it breaks, that's not good. So they basically, come to me and say, hey, can you look at our data and trying to figure out when things break? And I say, okay, great. Sure, that's something I can see if I can predict that. You've been saving data from your manufacturing process. I can use that. How often do things break and how much data do you have? And if the answer is things break, 1 in 10 million times, and we save data only for the last 20,000 parts, well, there's probably not a broken part in your data, and I'm not going to be able to solve your problem. And part of it is understanding that, hey, these are, what questions do you need to ask? Some of those are going to be, the ones I mentioned are sort of generic, like, do we have enough data for the circumstances that we're looking at? But it's also understanding that, some of the, sometimes folks don't necessarily keep all their data, we should check that. And then there's also the, how do I, some of these other things involving feature engineering. What features are important? Well, if I'm looking at a manufacturing process, for example, I'm not the engineer running the manufacturing process. I need to know, to find somebody who does, like, what does this, like, thingamabob plus one feature in the data that you're giving me mean? Is it relevant? Are there missing values all of the time? It really, understanding it at least at some level is essential. And if you don't necessarily, like, if you're new to the domain, you need to be able to find somebody you can ask the questions so that you can understand the data and the question that people, and basically the problem that people are asking you to solve. Okay. Let's see. Someone asked about applying learning from DS specialization courses to things outside of courses. Well, all I'm going to say is that getting things from classroom to application is always tough. The thing that I've found super useful is basically try to find some problem that could be solved with those techniques. Like, if there's something either at your job where you're working on data science related things, or some interesting side project you can think of that uses those tools, like, you basically have to reverse it. You're going from solution to problem, which is always tricky. So it's usually think about what things are you interested in, what can you do with this tool, what sort of things could you explore. It's always tricky, that. Let's see. How many tags do we have? So the total number of skills that we have is in the tens of thousands range. A lot of them are pretty infrequently used. It's one of those power law distribution things. There's a few tags that are really there's some tags that are really popular, and a lot of tags that are not as popular. So the classifier that predicts them, so that's, it's based on, we're essentially using some of those earlier data sets of, people labeling things as part of is basically some of the trading data. It's using, what was it exactly? It uses a gradient boosting classifier. For those of you who might be a little bit less familiar with that, the specific classifier basically builds a large number of small decision trees to try and figure out how to classify different, all of the different cases. And basically all of those not very great decision trees add up to a pretty good solution overall in the end. So the metrics that we use, we look at things like how often do people tag this skill to this course? How often do people tag this skill to the course compared to other courses tagged with a skill, compared to other skills tagged to this course? That sort of general thing. In addition to our sort of truth data, where we have had instructors tell us this is exactly a thing that is taught in this course. Yeah, anything with will Coursera offer X? I don't know. We'll see. It's a different team that works on that than me. But let's see. Other questions. Have you ever looked at trying to analyze the learning style of learners? Interesting. So we have looked a little bit at not preference to reading versus videos versus quizzes and other kinds of assignments. We have looked at essentially the way in which people learn. Do they try to do everything all at once, like they're Netflix binging on Coursera, versus spreading it out in a more paced and even way? it looked like, if you, it looked, in that particular case, it didn't look like there was a huge difference actually. But for looking at ratios of reading to video to quizzes, I'm not sure. We would need to have like two courses that are kind of similar, except that they have, if you want to do this in the simplest way, a couple courses that are kind of similar, except one has more reading and one has more videos. It could be very interesting. I don't think we've looked too much into learning styles, but it could be very interesting to examine. Oh, yes, serendipity and email recommendations. That might be our last question, but this is something that I'm really interested in also. So we've made some, so the email recommendations are currently undergoing a big rework to try and make them better. And that is exactly one thing that we want to test, is essentially adding a little bit more novelty to people's recommendations, adding a little bit of randomness. So keep an eye out for that in the future. All right, and that's about all I got.
That's great. Thank you so much, Rachel. And I want to thank everybody here for attending as well. I will be posting the recording of this webinar in the Coursera community, and I will be sending you an email with the link to that recording. I do encourage you to join us in the data science community, and you can continue talking about these and other topics that are of interest to you. And I want to let you know that we do also have additional events with data scientists coming up soon. And we will be posting announcements about those events in the community. And the community URL is coursera.community. And again, I will make sure to include this information in an email to you all. And just want to again thank you for joining us today. Thanks a lot, Rachel.
All right, glad to be here.
Bye.